Hello everyone and welcome to this webinar about mapping with BLK2GO and Immersal. If you have questions during the webinar, you can write them in the chat. Before I introduce our speakers, let me introduce myself and say a few words about what we do at Hexagon. My name is Paula Fortuny and I'm Product Manager. I have been working with the BLK2GO since the start of the development until now, and I'm based in Heilbronn in Switzerland, where the product is developed and manufactured. I'm also involved in other BLK products of the reality capture, which all focus on the simplicity of the complete workflow, contributing to 3D reality to become more intelligent and accessible to a wider range of applications and everyday users. So let's see how this fits in what we do at Hexagon. Hexagon is a technology company and a global leader in digital reality solutions that are empowering an autonomous, sustainable future by putting data to work. It's our belief that sustainability requires digital realities to push the boundaries of automation through autonomy. So let's see this in more detail. We every day interact with two worlds, the physical world and the digital world. And a smart digital reality requires a digital feedback loop between both of them. Hexagon core technology competencies enable this feedback with the use of 5 key areas of technology, which are reality capture technologies, enabling the digital capture of the physical world, positioning technologies, enabling for location, tracking, navigation, and or control of anything and anywhere. On the digital world, design and simulation technologies, enabling for design and replication of real-world scenarios, location intelligent technologies, enabling for georeferencing, and in between the real world and the digital twin, we see the autonomous technologies that enable for automation of any task, workflow, machine, or decision, enabling action without the need of human intervention. So the smart digital reality has 3 key elements, being one reality, being workflow driven, and being real-time and autonomous. We really can no longer think of 2 separate worlds as the physical world and the digital world, as we have one reality, and this is where the feedback loop becomes so important, because it's only when the data is available, it's live, and it's in context that we can make the best out of it. No matter the business or industry, it's all about the workflow. With Hexagon's unique mix of core technology competencies, we can create a sensor software system that integrates the right data in the right place at the right time, bringing speed and agility to any workflow. And by enabling real-time data collection and leverage and bringing autonomy to the digital twin, we can transform its function and utility far beyond a single source of truth. This is a quite condensed introduction of what we do at Hexagon, and it doesn't cover everything, but it helps to give a bit of the context of what the webinar today is about. So today, my colleague Matthew will present the BLK2GO in detail, and then Antti will guide us through the BLK2GO in Immersal, which is the augmented reality technology that helps to merge the physical and the digital world. I hand it over to you, Matthew.
Thank you, Paula. Hi, everybody. Very, very welcome. Welcome to a brilliant webinar today that we're going to talk about the Leica Geo-Systems BLK2GO handheld laser scanning system. That's for capturing environments quickly and easily. And we're going to talk about it a little bit differently today. We're going to talk about it in the way of using it for one of our other Hexagon sister companies called Immersal, which is augmented reality visual pinning amazing software, and how we are actually using a predominantly LiDAR-based system that captures images as well to actually use those images and the poses generated from the system to better build a visualization map. But I've got a brilliant developer with the name of Antti with me today, and he will be speaking about these details about Immersal and how they use the BLK2GO. But I want to tell you a little bit about the Leica BLK2GO system and how that's used. So BLK Autonomy is something on the forefront of our design teams. BLK2GO is one of those initial systems. So Leica BLK Autonomy vision is to make the reality capture fully autonomous. So from data acquisition and processing to creation of deliverables, insight and experience, capturing data autonomously and putting that data to work. That's what we're looking to do with this new BLK Autonomy range. So talking about autonomy, we've got another webinar coming up next week, the 20th until the 23rd, 24th, I think. It's all about BLK autonomy. It's about BLK2GO, the BLK2Fly, which is the world's first flying laser scanner, and the robotics module, the BLK ARC, or autonomous reality capture. These will all be showcased in detail next week with use cases and brilliant case studies. So please sign up for that. We'll be sending you a link after this webinar where you can register as well. But let's get back and get stuck into it. My name is Matthew Bester. I've been working with SLAM-based instruments for the past 8 years. I look after the business development part of the autonomy range, and this is for the UK and Ireland. And I'm based in Nottingham, the House of Robin Hood in the UK. So today I'll be introducing the BLK2GO. So the BLK2GO gives you the option to be free. It's a very simple and sleek system. It's got a multi-camera vision system. It's made for grab and go. It's got the dual axis LiDAR. It's got panoramic cameras to give you some situational and spatial awareness, but it also has a detailed orientated 12 megapixel camera to capture places of interest and details that you want to see. And we're going to talk about this camera system a little bit more in depth, especially for capturing for Immersal. So the system works on SLAM. So what is SLAM? So first of all, the IMU, or the inertia measurement unit inside the system, uses the distance meters, or the ranging from the LiDAR, that's 420,000 points per second, to actually combine and give you a estimation of where you are in space and time. So these 420,000 points a second are laser measurements that are tracked by the IMU in space and time, and that builds up a point cloud, as we call it. Together with that, we've got the 3 systems on the side and one in the front. So the 3 cameras together take pictures every single second, and it evaluates through the means of AI on where it is and triangulates itself to that specific position. So these 2 SLAM systems, so the LiDAR SLAM and the visual SLAM with the IMU, gives us what we call Grand SLAM. And that is the type of SLAM market leading technology that we use to incorporate into these types of systems. So it gives you the flexibility to just walk through an environment and capture that in 3D. So from a Leica BLK2GO, there's certain things that you get with the system. These systems are for rent, or you can buy them. If you want to know more about how, you can always get in touch with me. That's not a problem. If you have any questions with regards to the system or how to get a hold of it, you can always get in touch with me. I'll share my contact details at the end. This is a little carry case that you get. You can see there are batteries there, and you also get what they call a base. So this base is used to stabilize the unit when it initializes or starts up or deinitializes and shuts down. You'll be able to get that, and that's the only thing you take with you when you go mapping. Batteries, the batteries are, you get 3 batteries with the system. Each one of these batteries lasts around about, I would say, 45 minutes to an hour, and you can just press that button and it lights with LEDs and tells you what the charge is on these batteries. So it's quite handy to always know exactly how much charge you have left. We have an application as well, where it will tell you how much charge is actually on that battery, and that's something we can look in a little bit more depth later on. So around about an hour of continuous use per battery. Okay, so what we want to do is we want to insert this battery. So that's quite easy. Just put it in, it clicks into place, and there we go. Now we're ready to go go scanning. The system has a couple of features, and these features are communicated to the user through the means of an LED ring. So the LED, when you switch on as you can see, there's one press to switch on the system. It's currently in off mode. Then it goes to a solid and then a blinking yellow. This yellow just tells you there's something happening. It's in a transition mode. And after a while, it will go into a solid green. And that solid green, as you will see in a few seconds on the unit there, means that it is in waiting mode. So it's fully ready. It's ready to go. There we go. Green means go. And we're waiting for something to happen now. So in order to start a scan, we will just have a single press. So we press the button once, as you can see there. It's normally recommended to hold the unit still, because as the gyroscopes and the laser starts spooling up or starting up, it could have the tendency to wobble. So maybe just keep it still if you can. That pulsing green over there that you see there is actually, it's working at the moment. It's scanning, it's capturing data. I pressed the button once and you can see that there was a short little blink. That's a detailed image with a 12 megapixel camera. And there was a 3-second press which captures a panoramic with the 3 specific cameras around it. So that's a normal capture mode where you will use that. So it gives you clear feedback as to how to use the system continuously. Hold and press, or press and hold. You will see it actually turns into yellow blinking again. That will give you an option of saying the system is now shutting down or it's stopping the scan. Long press until it shows yellow again, will switch off the system. So you'll see there we go. So that's switching off the system now. Good. Now, to control all of this as well, to give you more feedback, we've got an application. The application is quite easy. As you can see there, the application is on. You connect it to a card that you get with the system. That same QR code is also in the inside of the battery compartment. When you want to connect, so when the system starts up, that solid green light, when it's ready to go, it generates its own Wi-Fi. You connect to that Wi-Fi through the means of that QR code. So that's quite easy to do as well. So when you start up the actual application, as we can see here, let me take you through that. So you've started up the system, you've selected the relevant BLK2GO that's already started up. You press on the relevant serial number for that unit, and you will be able to then scan the QR code to connect if you have not already. If you've done that before, it will store those details for you, and you will now be able to connect to that. So that little link means it's now connected. Now you are actually connected to the physical instrument. You can see quite a few nice things. So over here, you can see the battery life and also how much storage is open or available on the unit. You can either do it by flicking through the scans or grid mode. Then also you can have certain things or certain elements that you can investigate further. So the type of connection, the settings, so image compression. Do you want to compress the actual images? The point cloud density, which you can use in various situations. Some key statistics about the instrument. And then also if you have any reports, any issues with the instrument, it sends it automatically as a summary report to Leica support. So that's a handy thing to have. And then lastly, you can also how to scan. So all these things that I'm talking about now in a bit of a summary, you'll be taken to a website where you can actually scroll through how to start a scan, what to do when the scan starts, how to approach certain environments, wait until it's ready before you pick it up, what to do when you walk, how to walk it with it properly, how to walk smoothly with it. There's a couple of nice little tips. We'll go through that in a little bit more detail. So looking at that now, when you start up the scanner, so let's have a look there. When I start up the scanner with that single press, you will see that it says firmly hold the BLK2GO. That is preferred just to make sure that you stabilize the system. At the top there, you see that counter already picking up, and the actual points are actually accumulating. You have a slider on the right, which will be a Z slice through the plane. So it's a horizontal slice, taking you through the scan. You also have on the left-hand side this 3D view that you can view. This is 2% of the points actually being streamed. So this is not all the points, just a representation of what the scanner is actually seeing at the point in time. That little arrow would actually take you back to your current position if you've moved out of that specific scan. So that is quite interesting. When you look at the when you walk around, you'll see there's a little a green line that's being generated. That green line is what we call the trajectory line. So those are all the poses and the areas where you have walked. So walking outside now, if I press the button once again for that detailing camera, what we would see is that there's a flash, and there's also the actual picture that's taken. You can accept or not. And then when I did that long press, as you see here, when I get to that long press, will actually capture a panoramic at that specific position, and it will say panoramic captured at that point in time. And then you can obviously, switch off the scanner if that's the end of your scan. So looking at scan settings, these are the settings that you can adjust by connecting to an internal web page on the system, which is 10.1.1.1. Once you've connected to the actual Wi-Fi on the instrument, the SSID password is actually on that little card I showed earlier. So these would be, once again, the panoramic camera configuration. Do you want to compress the images or not? Also moving through the point cloud density, the full densities, so medium density or low density. Normally when you're walking through a challenging environment, like tunnels or darker environments, normally try and get the density full to make sure that you give the SLAM its best opportunity to be accurate. So let's put the BLK2GO to work. Let's see what the system does and how to actually use the system. We understand how to initialize and start it up and what the LEDs mean and these types of things. Let's see how to use it. So let's go through some best practices. Let's look at initializing the scanner. When we initialize or start up the scanner, as you remember, it's one single press. Get to that solid green state. Then press once to start the scan, hold the scanner firmly. When you do that, it's normally best to start in the middle of the room. Don't hide it in a corner, don't put it next to a wall. Try and start in the middle of the room. That gives the camera system and the LiDAR system a very good understanding of where it is, and it initializes that scanner. It's almost like a good morning routine. If you start off correct, the rest of the scan is going to be just great. So try and start it up in the middle of the room when you do initialize the scanner. And it is a cool piece of technology, I understand, but don't crowd it, don't smother it. Let the operator initialize the system, hold it firmly while it initializes, and once it starts up, you can then follow from a distance at the back and see how it's done. Stairs normally have an anomaly. When you walk downstairs, you can't see the front of it. It's a line of sight instrument, so the instrument won't see it as well, and that might cause some problems with the SLAM where it doesn't understand those features and it's a sudden drop away. Easy way to rectify: tilt the scanner 45 degrees forwards, and that's going to give it more coverage and more time to actually understand what's happening in front of it, and get those hidden features or those invisible features under its belt. Walking upstairs, that's normally not a problem because that's normally visible to the system in any way. Open doors in advance if you can. Moving objects, as Antti would say a little bit later, I think. Objects that move might be a problem, especially for the image map that you want to create. So try and, wait for the office to be clear. This is specifically capturing for Immersal. If you're capturing for normal mapping, that's not a problem. But, walk purposefully and try and cover as much of the area as you can. Double back on yourself if you need to make sure that you get all those angles that you want to get, especially from an imaging perspective. Remember, we take images every single second with those cameras, so think about that as you move through the space on what those pictures would look like and how that would affect your map at the end. So once again, holding the scanner properly in front of you, arm's length, keep it comfortable. Line of sight instrument, the cameras see what you want to see. Make sure that you've got that visibility. Think about that while you move through the space. I call it the full cup of water walk. It might sound strange, but walk slow but purposefully. you don't have to run with it. It's not made for running. And just think about how you move through that space. When you moved into a new space, so with other words, going from one room to the next, maybe stand in the doorway and wait for points to build up on the other side of the wall in the new environment. Use your app to get that visual confirmation. It takes around about 1 to 2 seconds to actually do that, and the SLAM has now taken a grasp of the new environment and understood it. So it's not something brand new from 1 second to the next. Remember, the system has a 0.5 to 25 meter LiDAR range. So moving to very tight spaces might not be the best thing for the LiDAR, but also for your images as well. Keep at least 1 meter away from walls to give that system a good chance to give you the data that you require. Walking in one direction gives you some perspective. Maybe walking back on yourself will give you some additional angles that you could use. Maybe think about that as well. The most important thing is to plan your scan. So break down your environment into sizable or achievable sizes. Get good overlap. When I say overlap, I'm talking about 30% overlap. Approach hallways in one go, for instance. Try and keep the doors open. Really think about how you approach your environment prior to scanning and what you want to get out of it. That's very important. Sometimes when you walk downstairs, give it about 2 to 3 to 5 seconds on the landing. Just give it some time to really look at its environment and then move forward. Multiple walks, especially multiple stories. Try and use the stairs to actually as a tie point, if you want to put it that way. The fortunate thing about capturing for Immersal is that multiple walks can be stitched together, so you can create quite a large map. So that is quite exciting stuff. Moving objects, I think Antti will go into this a little bit more detail. Moving objects can normally be cleaned out in the Cyclone Register 360 workflow. Once you've imported the scan into that system, you can normally clean out that noise quite easily, but that's not something we can do for Immersal because we're using the images and it's going straight in as a raw B2G file. So be cognizant of moving objects and doors and cars and these types of things. Just think about that. Corridors and tunnels, try and break that up by going into the rooms, doing a zigzag motion through that environment, and try and capture it all in one go, or break it down if you need to. If it's a very long tunnel, try and break that down. If it's a little bit dark, maybe use a lighting rig so you can get optimal visuals from that specific environment. The facades, walking around an area, maybe break it down in two, so capture as much as you can walking around, and then the next one just going up and down that facade with the scanner to try and capture as much as you can from that facade. Or you can use a very long pole. We've got poles for hire as well with the system, as well as the light rig. It comes with a lot of accessories that you can get. Get in touch with me if you want to know how to do that. And you can actually walk with that on a pole and really capture some really good data, as you can see on the right hand side there. Outdoor scanning, I would say keep your scans a little bit smaller and make sure that your overlap is about 30% at least. That's just making sure that keeping in touch with the fact that we've got a 0.5 to 25 meter range on the instrument. We want to make sure that it sees as much as it can. And outdoor, you've got a tendency to walk with this piece of equipment. 20 minutes goes so quickly. So just try and plan your scan, keep the scans smaller so that you can stitch them together and have a nice overlap on those outdoor scans. And then underground tunnels, once again, I would suggest a lighting rig, especially for capturing for Immersal, for the images. Try and get that lit up so you can get those images nice and bright. These areas sometimes tend to be dangerous, so make sure that you've got all the relevant approvals and these things to go into those spaces. Forests are quite a thing that's been scanned plenty of times with the BLK2GO, especially in the forestry industry. Capturing for Immersal, I think it might be a bit of a problem due to the nature of wind blowing the trees and it's moving objects. And once again, my great friend Antti from Immersal will tell us why that's a problem when you want to create a visual map with the images with that specific one. Okay, so we've started up the scanner, we've connected the application, we know what the application does, we know what the LED is telling us, we know how to walk through environments. Now it's time to actually get hold of the data. So the data that we want to use to start bringing into the Immersal side of the workflow, so we can get that 3D. So we've got a USB-C to USB-C cable where we connect these two instruments, your laptop and the scanner, open up the battery compartment, and we insert that little USB-C into the slot provided. When we're looking at the actual extraction, we've got a little utility, a free utility called the BLK Data Manager, and that will connect or see that the BLK2GO is connected. When you say connect, it brings up all the relevant scans that you've done, and you can actually just drag and drop those B2G files out of there, or just download them as you wish, depending on what you want to do. So that's how you extract the B2G files. The file name is normally the serial number of the scanner and followed by the number of the scan or the number of the walk that you've done. So you can save any one of those files where you need to with the BLK Data Manager. Good. So the normal workflow is plan your scan, upload it either to HXDR, which is Hexagon's digital reality platform, where the scan is automatically processed and meshed, and there's some data analytics by clearing moving objects. Very beautiful stuff. Or alternatively, going into Cyclone Register 360, where you can clear noise out of the scan, remove moving objects, join scans together, export in different type of point cloud formats. But that whole workflow is not what we're going to talk about today. We're talking about Immersal and capturing for Immersal. Very exciting stuff, and I think that's something that Antti will tell us a little bit about more. So once again, we know how the system works, how to initialize it, how to walk with it, how to use the application, what to look out for, what's the best practices. These systems are easily available globally for purchase or for renting. Get in touch with your local Leica distributor or with me. There's my contact details there if you'd like, and I'll be able to point you in the right direction to get your hands on one of these instruments for capturing for Immersal. If you have any questions, you can send them to me, or please just type them in the questions section in the webinar at the moment. We're going to try and get to them all if we can. We will be having a live session as well after this. We will send you a link so that you can actually join a Teams call, and we can have a little bit of a chat to you guys on questions you might have. But for the moment, I'm going to hand over to Antti. I think you're ready. Thank you very much.
Thanks, Matthew. I wish to talk about large area mapping for AR with Immersal. I'm going to go through just a little bit about Immersal, briefly about mapping different sizes of locations. I'll give some examples of good locations and some challenging locations. I'll also recap the Immersal workflow at the end. My name is Antti Pehkonen, and I'm a client-side software developer at Immersal. And my background is in sensors and real-time visualizations, mainly in maritime. A couple of words about Immersal. We are a visual positioning technology company. It's typically used for location-based AR. So our solution is two parts. First, we create a visual positioning map using images. And the second part is that we localize ourselves within that map using an image. We provide online localization for example, low power devices. Offline on-device localization is possible as well through our plugin, for example, on mobile phones. And we have an SDK for Unity, which is a popular 3D engine. The on-device plugins are available for mobile phones, HoloLens, Nreal glasses, Linux, to name a few. And then there's, of course, the REST API for everything else. Now, in the past, we have relied mostly on mobile phone mapping, and this is good for small targets and medium-sized targets. Well, medium-sized targets start to become cumbersome already if there are corridors and rooms like inside a typical house. Large areas have been time-consuming to map, and it's really easy to make mistakes there, and the maps can fail for a number of reasons. Today, we support a device that lets you walk through a space and map consistently. And with Leica BLK2GO, we're seeing 10 times faster mapping time on site. And the AR map construction time on our servers is reduced from quadratic to linear with high quality post data. Now this is awesome. Basically, the bigger the map, the larger the benefit. I've even seen 70 times faster construction times. What does Immersal take as an input for a visual positioning map? To put it simply, we require images and poses. For mapping, we're using a process called structure from motion. It's a well-known approach, and we add our own technology on top of it. In a nutshell, we look for similar features in a sequence of images and triangulate those in space. And for localization, we look for features in a single image and compare that to a map. And the output is a position and rotation of the point where the image was taken from. And the theory of a visual positioning map is that it roughly works in the areas where you walked in while you were scanning the material. So what that means is that when making a visual positioning map, keep in mind to capture viewpoints that your end users will be seeing. And this is important. The Immersal Cloud service is directly compatible with the raw B2G files. And this is the file format that Leica BLK2GO outputs. So this is good news for our customers. Let's talk about environments. Now, it's really challenging to have a one-size-fits-all definition of a good environment. You can read the do's and don'ts in our documentation online. A number of things affected. It could be the season of the year, the lighting, dynamic content. Can you update the experience when something changes visually? A couple of examples that could be good environments for Immersal. A museum experience. We have a nice test bed at the Helsinki Natural History Museum. There are good objects for AR mapping. For example, dinosaur bones, sculptures, they have a static lighting. Some scenes and settings are behind a glass, so there are reflections present, but it seems to work well. Another environment could be a street or a courtyard. Now, not all streets and courtyards are created equal, but the best ones would have tall, non-reflective buildings. Then the dynamic environment at ground level does not matter as much if the end user will see much of the static environment when trying to localize. A use case could be visualizing underground piping. A third example is an office with a unique layout and non-reflective surfaces. I've seen a great use case with HVAC simulation visualization. Having said that, some offices can be challenging, of course, so test before committing. Fourth example that I'll give today is a movie theater lobby. Immersal maintained a movie theater lobby for 2 years in Helsinki. We implemented an indoor navigation, we had games that the customers could play and win prizes, promotional content, things like that. That was a positive experience. Now, something to know regarding scanning. A good-looking scan might not be optimal for a visual positioning map. This is mainly due to the second part of Immersal solution, but can affect the Immersal map creation already. I'm referring to reflections, repeating patterns, etc. mentioned earlier. Immersal is trying to localize a seemingly random image in a VPS map after X amount of time. Even though the map turns out visually correct to human eye, Immersal might not be able to localize in a dramatically different lighting or wonky reflections. Yeah, but can you edit out the bits that are misleading? Well, unfortunately, currently you cannot edit the visual positioning map with Immersal. A real-life example of a challenging project: a river cruise in Singapore. The intention was to provide an AR experience looking at the shore from the ship. It's challenging to map that, and it's challenging for the end user to experience that. The boat is moving slowly, so the visual look of the buildings is not really changing that much. The laser of the BLK2GO is not reaching the buildings that are a couple of hundreds of meters away. And the mobile phone tracking, it has this limitation that the visual features are not changing very much, but the IMU sensors are picking up the boat motion. So there's a struggle between detecting motion and the visual features not moving. Another example of a challenging environment, or which I would perhaps advise against, is a forest. Forest is a very dynamic, living and changing environment, and there's lots of details that can be picked up, but they can change ever so slightly. So after the material is captured and you've created your AR map, you come back in 2 weeks and find there's a lot of things that have changed. The leaves, the needles of the trees, all in different position. Our system is simply not tuned for that. Third example that might prove to be challenging with Immersal. Have a look at these pictures from a hospital corridor. Here's floor number 1, 2, 3, and so on. They pretty much all look the same. It's very repetitive. It would be really challenging to create a full building indoor navigation system. I think you would get a lot of false positives trying to localize there. Now, having said that, with some clever logic, you might be able to get it working. Variable lighting is a challenge many of our users have, and I'd like to give a tip on how to battle that. I've experienced in the past that lighting conditions during morning time, daytime, nighttime, and artificial lighting, they look very different for the Immersal system to localize and understand if they are from the same place. Strong shadows can be picked up as unique features, and the next time of the day, they are not there anymore. So a good way to battle that is by mixing the images from different maps into one bucket and creating a new super map. So basically what that means is that you have maps from different lighting conditions and you put them all into the same workspace, and then you use our service to create a new map with those source images. The theory is that it will try and find the features that stay the same regardless of the lighting or can be recognized in any of these lighting conditions. So this should give you the best possible map and the best approach to battle lighting. A quick reminder of the workflow. What happens after you have captured the material? I'm sure many of you are familiar with this, but just as a reminder, once you have done the scan, especially with the Leica BLK2GO, you've got this beautiful raw B2G data file. Our service is directly compatible with that data. So we upload it to our developer portal, and after the processing is done for the raw capture file, it's basically the same workflow as for any map in Immersal service. You set up your new Unity project, you download the map that you've created and put it into your project so you can visualize the map. And these are not the LiDAR scans that Leica produces. This is a visual positioning map, and it's visualization created by Immersal service. So the map visualization can be used as a reference for placing your content. And the map can also be used for offline on-device localization. So you place your content and set up the logic for your experience as you would for any Unity application. And that's it. Then you're ready to build your experience to the platform of your choice. Okay, we're reaching the end of the presentation. If you have any questions, please type them in the chat. Each question will be answered. We're hosting a live Q&A in a different link, and the link should be in the chat. I'll finish with a short personal video I made during the summer for fun, showing the workflow briefly. I want to remind you that the point clouds and textured VPS map that you see in the video are Immersal produced, not Leica produced. They are meant for debugging. Thank you.
Wow, thank you, Antti. That was really, really good. Interesting stuff, fascinating stuff. We've learned a lot. I think there's a lot to take in. I think we definitely need to do some more webinars. I think Immersal is amazing technology. So proud to be part of Hexagon for being able to join these types of technologies together. I'm sure you've got a lot of questions. I will be very happy to answer all of them. Unfortunately, we can't do everything on the webinar at the moment. We have sent you a link to a Teams call that you can join right after this, and we'll be live, Antti and I, and we'll be able to answer all of your questions that you might have. Those of you that have entered those questions into the webinar chat or into the question section, don't worry, we'll get back to you as soon as possible. We'll give you a full explanation and answer your questions as best we can. Thanks for watching. Speak to you in a few minutes. And yeah, thank you very much for your time.